Welcome to the science class of Prakash Academy. Have you ever wondered what happens when you mix a shiny piece of metal with a strong acid? It's not just a simple mix, it's a chemical reaction. And it's pretty cool. Think of it like a dance. When a metal meets an acid, they swap partners. The metal decides it wants to join the acid, kicking something else out in the process. The general formula goes like this. Metal plus acid gives you salt and hydrogen gas. Imagine you take a small piece of zinc, a common grayish metal, and you drop it into a beaker of sulfuric acid. Instantly, you'll see bubbles streaming off the surface of the zinc. You carefully collect some of the gas coming off the reaction in a test tube. Then, you take a burning splint and bring it to the mouth of the test tube. If hydrogen gas is present, you'll hear a distinctive squeaky pop sound as the hydrogen ignites. Now you might be thinking, does every single metal do this? That's a great question. And the answer is no. Some metals like potassium and sodium are super reactive. They react with acids so violently and explosively that it's extremely dangerous to even try it. Then we have our moderately reactive metals. This group includes familiar faces like zinc, iron, and magnesium. On the other end are the less reactive metals. Think of precious metals like gold, platinum, and silver. It all comes down to hydrogen ions, written as H+. For the reaction to occur, the metal has to be more reactive than hydrogen. If a metal is less reactive than hydrogen, like copper or gold, it simply isn't strong enough to kick the hydrogen out. Just when you think you've got it all figured out, chemistry throws a curveball. Meet nitric acid. While it is certainly an acid, it has a second identity that changes the game entirely. Nitric acid is not just an acid. It's also a very strong oxidizing agent. This powerful oxidizing ability means that when most metals react with nitric acid, the reaction follows a completely different path. Because nitric acid is such a powerful oxidizer, it messes with the hydrogen that is trying to form. As soon as the hydrogen atoms are created, the nitric acid swoops in and oxidizes them, usually turning them into water. Instead of hydrogen gas, the reaction typically produces water and various nitrogen compounds. There is, however, a fascinating exception to this rule. Consider two specific metals, magnesium and manganese. When these particular metals react with very dilute nitric acid, they actually produce hydrogen gas, just like they would with a normal acid. The story with nitric acid gets even stranger when you use the really strong stuff. If you take a reactive metal like aluminum, iron, or chromium and drop it into concentrated nitric acid, you might expect a huge violent reaction. But something amazing happens, almost nothing. This phenomenon is called passivation, and it's like the metal is suddenly wearing an invisible suit of armor. This passivation effect is actually incredibly useful in the real world. It's one of the reasons why stainless steel is so resistant to rust and corrosion. By intentionally creating this super thin protective oxide layer, we can make metals much more durable and long-lasting. So, from the simple fizz of zinc and sulfuric acid to the complex, colorful reactions and sudden passivation with nitric acid, the world of metals and acids is full of surprises. These reactions are fundamental to our understanding of chemistry. They show us why some metals are perfect for making jewelry, while others are used in batteries. Understanding these interactions allows us to control them, using them to create new materials or protect the ones we already have. The simple act of a metal meeting an acid opens up a universe of scientific principles. It's science and it's everywhere.